Hi, let us do a simulation of starting of three-phase induction motor from the beginning. We take a Simlink browser, their Simscape, electrical, specialized power system. Then we have here specialized power system. Then here we have power GUI. So this can be continuous, or we can have the tool like F50 analysis over here, or we can have this a discrete 50 e to the power minus 6. Next we have electrical machine, obviously three-phase induction motor. If double clicking it, we can get the parameters. There the slip, make the slip 1 starting from 0. Okay. Next we choose the supply source. We can have a three-phase supply over here. Again, click over here, press the control button and click here. Then you need some commonly used block, constant. That constant will give a constant torque over here. Double click, change the value, apply. Okay. Let me decrease the size so that we can have both the things together. Now these things I want to take this side. Okay. Next is okay. This is kind of torque over here. And then okay. And then we need a scope. This scope, after double clicking over here, what we can do is we can change take the configuration parameter. Logging here, we can put in a data scope data, structure with time, then display, and here this will not work here. Rather we can go for view, configuration property. Okay, in the main it is there. So the layout, let me say we want 4, and the 4 like this. So we can have we will apply. So we have got a 4 in possible in a single scope. Right. So we can write here what are the in over here. We can change this. We will do it later. Also we can go to the style. In style you just can click here white, figure color, axis color white, and this one black. And inside it you can choose red or any other color. Apply. In second display you choose another color, black. Okay. Then third you choose another color, maybe blue. And fourth you can choose another color, maybe green. Okay. So now we have 4 scope in a single one. Okay, so now I just need to enlarge it and just keep it over here. Now I need a bus selector. So bus selector, I can get the output of the induction motor. Double click on bus selector. You can see that the signals are there. Remove it. In mechanical, I need a mechanical speed. Select. Mechanical torque. Select. Then we have a stator current. Then we have a rotor current. There's 4 we need, and that's all. I can enlarge this one. Okay, it looks good. Now I can click it over here. Then I click over here, so all the 4 get connected. Now this side, the rotor, let me short it. So it's like a squirrel cage induction motor. Let me run it for 4 seconds only. And wait, this supply we need to change. This is saying phase to phase RMS voltage. That means line voltage. So 380, frequency 50, and internal source resistances. So let us say this is not the idle source. So we have idle source over here, and let me run it now. So now you can see that it's a simple induction motor, 3-phase supply, and we get some output on the scope. What did we get? Is this what we get here? So here we have got how we see it, and there how we want to zoom it. So now if I want to zoom and see that what are the transient part, I can zoom it from here to 0, and still I can zoom it further, let us say up to 0.2 seconds. Okay, from 0 to 0.2 seconds we have the speed. The speed is getting settled at 0.1 second, nearly 0.12 seconds, and the electromagnetic torque gets settled in 0.18 seconds. The stator current is settled in 0.14 seconds nearly, or 0.18 seconds everybody gets settled down. The torque is over here. This is electromagnetic torque, and here we are with the torque. Torque is 10 Newton meter, and not exactly 10, but of higher than that, 10 point some value. Okay, what we can do is we can have a display over here, sync. Also we can see the display, and here we have a rotor speed. Lot of glitches. Let me pick it another rotor one. Here we can see the torque, and with the commonly used block we can use anything. Yes, we want to see the speed in RPM. So for that reason I have to remove this. Let's connect again. that gain value is how much? 30 by pi. That is actually convert from radian per seconds to RPM. And we can connect it over here. Now let us run it for 4 seconds. So now you can see that 1490 RPM and the torque is 10.92. External torque is 10 Newton meter. The motor is also running, so it is around 0.92 Newton meter. Total is 10.92. Speed is 1490 at 10 Newton meter. 10 Newton meter torque. So let me increase the torque to, instead of 10, to 50. In that situation, let us see what happens. So torque is 50.89 and the speed is 1452. How far I can go? Instead of 50, let us say 100. So if you take up to 100, 100.9 Newton meter and 1396. So suppose I will say not 100, let us say 1000. In this situation, your motor is not working, right? It has gone to the negative speed and the torque is nothing. So I just make from 100 to 1000, right? So let us make it 500. So when we make it 500, it's still nothing. So it means nothing. So when I get 100, it is giving me some results. Let us say 200. When I get 200, it still gives, see that electromagnetic torque is around very less, 0.012. So let's just make it 200 is not working, 150. 150, yes. It's not going again. It is falling back. 0.12, nothing. It's like you were getting back to what? 125. Yes, it is working for 125 Newton meter. You are getting some output. Up to 135. We are getting some values. 135 also. Okay, 140. It's failed. 135 it's okay, but when you go to 140, you can find that there's a negative speed, and you get. So if you see this waveform, it's a negative speed is there. You are actually falling down. The speed is revolving in other side, like the torque is much above. The electromagnetic torque fails. Stator current its motor is gone to the stop now. If I run up to more than that, so let me say 135 is the best. 136 Newton meter. So it's okay carrying out 136, and 1345 is the maximum speed. The speed that can decreases 1345, and here we can get some result. This is how the speed get changes and we get results like this. If we see the current waveform in a steady state, you can see that it's lagging at 0.16 and 0.162. It is here, so it's 50 Hertz, right? So the stator current is 50 Hertz, but rotor current rotor current is of something different, like from here to 1, 2, 3 cycles. Okay, these 3 cycles, let us say we are 1.7 something, and this is reaching here at 1.9, so 0.2. You can see that the rotor frequency has decreases, time has increased, and the stator frequency is 50 Hertz. Okay, so that's a reflection out of it. So in this way, we can see that here the upper is this rotor is not written here, so we can rewrite that. Okay, so here we can write. We are not able to get here, right? So we can take this configuration parameter and display the signal. First signal we can write here rotor speed in RPM. Okay, so rotor speed in RPM, determine torque, stator current, and rotor current. This way you can show all the 4 parameters together. If you zoom it up, you can show the transient part, but like this you can show it perfectly, and you can take any other load and do it, right? So this is what about the starting of 3-phase induction motor. But this gives a squirrel cage. So what are we are interested to add a resistance over here. So passive elements, here we have RLC branch, and I double click it, take the value of R is equal to 10 ohm, apply, okay. This 10 ohm you can squeeze it like this. Now this one you can join. We have set it 10, right? So Control C, Control V. Another Control C, Control V. So just add these 3 resistance in the rotor side, right? Just like this. Oh, not connect. Yes. Sorry, we need to connect it. Connected. And the other side of this rotor resistance, we need to short it out. Correct. So when we add 10 ohm resistance, maybe it will not affect, but let us see. If it have 10 ohm resistance, then 1345 was that. Oh, but we are getting a negative speed over here. So that means, what does exactly means? The speed is falling down. See, by adding a 10 ohm resistance, the rotor is not able to move because the starting torque is not enough for it to drive in the forward direction. It drives in the reverse direction. But if I change it to 136 to 100, probably it will work. Still it's not working. Okay, let me make it 60. If I do it 60, it's working, right? It's working. From 60 it is rising up, but it is not going way far from that. If I run it for more than that, 4 seconds, then this is 528. If I run it for more time also, this is still coming 528. So 4 seconds is okay. Right. So if we run for 4 seconds, we are getting a steady state. So let us run it. And let's double click that. And here we have like this. Obviously the starting current has reduced, but the speed has reduced also. And then if we this is 10 ohm, right? So if instead of 60, if I have 30, right, then what? Then I'm reaching up to 1028 RPM. So that's it. There's a difference. And we are not getting any overshoot, we are just getting a straight line. And if we increase the resistance here from 10 to, let us say, 20, okay, let us say 50, right? Apply this thing to all 50, here 50, and sorry, this is also okay. It's all coming 50 because we are not we need to keep it a little bit right. This one down, this one up. Yep, this one is 10, so that is also 50. Okay, great. This one, this is 10, this is 50. So after making it 50, we have different results, like 1028. Oh, it is going negative, right? So you have to choose this resistance value very you need to do calculation what value should you use. It's not like in simulation we can just say that 10 Newton meter if I apply, might be it will work. Its speed is, yeah, now it is running forward direction. So thing is that this rotor resistance, if it exceeds a certain value, the motor may not run in a forward direction, it may reverse, just like active load. Maybe the starting whatever the jerk is required, like that is not there, so it will create a problem. So that's why this resistance is to be chosen carefully. We can also make the resistance gradually decaying, like how we will do. Suppose instead of that 3 resistance, suppose I will just take only 1 and keep it here. Control on, it will rotate, that's all. I will remove this set. Rather than that, I will use a power trim device and I will use a diode. Where is it? Here. Control R. This diode, I will remove that measurement part, not required. I just need a diode and small size. Okay, here I just need a uncontrolled one type of rectifier. Here it's a practice of 1 3 like that. We keep the thyristor in that way, not the diodes, but for active kind of thing you can keep the thyristor over here. So now I want to join these strings and we need to short out these things. Then you need to short this side. Yes. Now these three resistance you can add in this way, in R, this way, like in Y, and this way, this B. So you can connect like this, and you can have the working with single resistor. If we run like this 750 we have seen now. Let's see what. Oh, instead of 750 now we have 1065. Its effective resistance has decreased. Effective resistance has decreased. So if we see the curve, so this is the new output. You can see the current is sinusoidal, but the rotor is no longer a sinusoidal current, rather it is a distorted current. These distorted currents having a harmonics in the rotor, and there will be a ripple in the torque. You can see that the torque is full of ripple, right? Okay, let me just zoom it over here. 10 Newton meter I have given. It's something like this. So if I zoom in the x-axis zooming, so it's like these ripples are available in the torque. Earlier it was not there. When the rotor current is sinusoidal and the stator current is sinusoidal, we are getting a torque straight line. But when we use a power train device over here with the resistance, we get this type of things on the torque side. Like there is a ripple over here. So in one way, this electromagnetic torque, this is not a good thing that you have a rippling of this torque. And speed is okay, no problem. Speed is fine, steady state. But the torque at ripples. So that's some drawbacks of that. And here also you can have a variable resistance by using a chopper over here. And you change the duty cycle, and that's where you can vary the resistances. And in this way this will work. So thank you. And starting of the 3-phase induction motor using rotor resistance, either you can connect directly or you can connect in this way. Thanks a lot. Take care. Bye.